So, I'll leave it so that I can see the time. Okay. Greetings. Welcome. That's the stuff. Do we have a team name yet? I forgot. What? The favorites. Okay. It didn't get me revved up, but I mean, you're my favorites. Okay. We will consider it then. Okay. We have, this was Friday, we looked at this kind of a graph here. If you have a positive slope, so we said maybe positive is west, and you're going up, you're going west. You're flatlining it on a distance, a position time graph, distance time graph, you're not moving. And if you have a negative slope, that just means you're still moving, but the opposite direction. If it's a right-left thing, it's probably negative is left. If it's an east-west thing, the way I define this one is that the negative was going in the east. We talked about that. And we know how to calculate slopes. Then Ray and I walked this one out, right? And distance north. Well, this would have been going north, standing still, going north, but slower slope or slower rate because the slope isn't as steep. Then turned around south, stopped, went back north, and ended up at the exact same starting position. Whereas the other person stood still and was south of the other person at the start. Stood still, then went at a fairly decent rate towards the north, with positive slope, then stood still. So I've described the motion. We walked it through and kind of experienced it on Friday, right? So what I'm going to do right now is hand these sheets out. We're going to discuss these. Each one of these, we're going to describe A and B's motion. I only gave you 3, right? Yeah, okay. So I'm going to talk. You guys are going to jot down descriptions of it. Let's just assume, and I'm going to turn around so my right and left hands are positive. Let's assume that going to the right in this classroom, that's actually the west, is positive, okay? So let's describe A. This, then this. It's positive both times, so they are traveling to the right. But how does the first part of the journey compare to the second? There is a difference. Graph-wise, it's less steep, so what would you say as far as A's journey? Starts out right, quicker and then slows down after, I didn't give time in seconds, but we'll just say a few seconds. Slows down after a few seconds, but still continues to the right. Wanted to say something like that. Yeah. Okay. And then B. It's responsible for driving. Not very high. What about B? Well, we don't have anything right off the bat, so we're going to assume that B stands still for the first few seconds and then goes at a steady speed to the right. Right? Does that make sense? What kind of modeling? There is one thing too, though. If something's impossible, you state it. This comes back to, remember the vertical line? Well, basically, you can visually see that these have to be functions for the value. Now, both A and B can't be realistic situations. a vertical line test. But just knowing that there's this vertical line test, it's not a function. You've got to be able to describe why. Let's go with A, because A is first. Bang, this is okay. This is okay, but what's the problem with this? Vertical, yeah, but what's the problem physics-wise? What would that mean? Not even, it's not that you're traveling, it's traveling to the right. You're traveling to the right, but what are you doing right here? That still would be, this is why I'm getting through this. Not necessarily stand still, because that'd be a horizontal line. Yeah, shall we? A. Kind of like teleporting would look like this. Bang, and then skip. Bang. Wouldn't it? That would be teleporting. This would be that you were in 1, 2, 3, an infinite number of positions at the same time. That's why this doesn't work. Because, and like, you know how it's a portion. I could put as many dots as I wanted. That's what I'm saying. An infinite number of positions at the same time. It doesn't work. A doesn't work because in the middle, at one point in time, you would be at multiple positions. Does that make sense? Impossible. And this is why I'm going through this. A vertical line. Impossible because, though, I want you to say in the middle, you were in multiple positions at the same time. Okay? That's what that represents. Thank you, Ray, for talking about it. Now, B is a bit more, it's not infinite. It's pretty straightforward now, can't it? Yeah, B. That's the thing. It's sort of, you could think traveling back in time, but it would, I know what you're thinking. If you're thinking this is your starting point and then you went back in time, and that doesn't work because I could still say that this is the starting point. It's that you were in two positions at the same time. And I guess you could say it's going back. But it's nonsense too, because at this point in time, you're in two positions at once. And many, you can't be in two positions. Let's say it doesn't work because it's impossible. You can't be in two positions at the same time. You really need to twist it around. I know that, but I'm telling you, you're not. You need to twist it around. I want you to work with me. Don't trick it back. Yes, Tom. Give a theory for these, but I guess you could be identical twins. But one object is one twin. I see what you're saying. Yeah. Or you could say that this is you and then you in a mirror or something like this, right? But it doesn't work, right? We're talking one object. You could use, it's not a valid thing. If I'm walking to the right, I see a mirror there, okay. I'll pretend. My mirror image, I'm walking towards this mirror, is walking to the right, boom, 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 boom. You plotted them both, it would look like that, right?
Yeah, so it is possible.
But it's not one object.
Yeah, it is one object.
Yeah, my image is, we know that we did mirrors last year.
Yeah, I know.
Images are different.
So it's possible.
But if that was the case, then I would color code it one dotted or different color. So I would say, this is my mirror image. This B is still impossible. You can't be two spots. It's not one object. If you said that they're two different twins or mirror image in yourself, you could say that, but then it would be two different graphs. It would be B and C.
Why is it possible?
You can't be two spots at once. An object can't be in two spots at the same time. I know, you guys just come up with stuff. I've heard a lot of it over the years. Okay, these ones are possible, so we're going to describe them. Okay, let's describe a okay. So what does A do at the start? There's three sections. Or say to the right is positive. So A travels right. Then what happens between here and here? Yep. Gotta be moving left. So now to the right. Now left to the left to the left. Okay. Bang, bang, and then to the right again. To the right, to the left. Whereas B just goes to the right, then to the left, and returns to the initial position. Well, that can you add that in? So this is graphs without numbers, but if we had them, we know it's at the starting point. Okay, we did the group discussion stuff. On the opposite side, we're going to refresh ourselves. These slopes don't have units yet. Okay, we will talk about when you have units. But ABC, you guys know this stuff, I'm hoping. You can do it by squares and counting, although they didn't show up that great. You can imagine there should be a line through there. Anyway, if you want, or you can do it by y2 minus y1, x2 minus x1 on the bottom, right? You know how to do rise over rise. Whether you do it by counting squares or whatever, make a fraction. And then it's a science class. I want you to just divide and get decimals. 1.75 instead of, 3/4. Okay? Stuff like that. This one here, is there any calculation to do? Nothing, zero. Then, I'll talk to you, and that's just a review, and we'll go over them. Oh, I have the answer. Okay. Find the speed for each section. Now, the velocity on a position time graph include property units. The velocity on a position time graph is slopes. And we knew that from our last. Property units and direction in your answer. You notice how I put position in meters, and it's N for north. We'll just assume positive is north, negative is south. The time is in seconds. So when I do rise over run here for the first one, and I'll just do this right on the graph. I think, okay, I got a rise 0 to 45. So I've got 45 meters. Does that show up for you guys? And then I'm going to divide by a run of 30 seconds. And it's meters. I'm going to put even the square bracket for the north, because that's different than south. Okay. So when I do that, I get meters per second in my apps. And I can do this one in my head, 1.5 meters per second. And then I'm going to put a square bracket. If you get a negative, you could either call it negative north, or be consistent, just say the number south. And that'll be for this region and this region. You have that choice. Okay? So that direction is important. So 0, I don't care if you say north or south, you can just put 0 meters. No calculation. And these are easy enough calculations. If you could do them in your head, go ahead. Or do it, like you don't have to show where, because I'm assuming you know your slope. Okay? So you guys finish off this page, and then we'll be just ducking. Okay, we have rejoined Physics 30 in the AM in progress. You guys are jotting stuff down. It's not over. Okay, now these slopes, I said you could do by just counting here. 1, 2. I'm having a hard time. I'm going up. So that's a rise of 4 over a run of 6. Right? So I'm hoping you said 4 out of 6. Now, I had the question, should I put decimal 6 with a repeating bar over top? In science, let's just terminate our decimals. Now, you remember something about significant digits that I always harp about in physical science? This truly doesn't have, you can go on and on and on because these are exact. 4 squared is exact 6 squared. But 6, 7. Okay? We'll terminate our decimals. Don't put the 666 repeating dot dot dot. But this one, down, whether I go down here or here, either way, it's down 4. I make a mistake, you guys call me on it. Over 8. Okay, we're good? And this one, no calculation required, 0. Good. Now these ones, I had the first one shown as a calculation. The other ones I have here, but you guys are going to ask me questions here if you need clarifying. I wrote answers in both forms. Whether you put -3 with north, negative north, which really negative north means stuff, right?
How did you figure that out?
Sure. This is exactly what we need. So this portion is a drop of, so that's what I need. 5, 10, 15, 20, 25, 30. So 30 divided by, and that was only over 10 seconds. 30 divided by 10, so 3. Now, if you didn't count squares, you could always say, well, 60, the difference between 60 and 30 is 30. Right? Because sometimes your graphs will be too big to count squares, and you'll just do the subtraction. And you know it's negative going down. Similar thing for E. Keep asking questions if necessary. Are we all on track with this? Okay. Now, what is about to get
How do you tell where you put that?
where do you put which? Sorry.
34 into 10.
More specific. I'll do my best to answer.
Yeah, so for 8, it's 0 to 30, so how do you know what those say?
Hang on. I'm being asked questions. That's a good one. So, 0 to 30, right? That's 30 seconds. That's my time frame of 30 seconds. So that's what, okay, I'll just review. So from here, from this dot to this dot, climbing from 0 to 45, right? That's where I came up with that. It's positive, so I know it's not. And then divide by the 30 seconds. Yeah? No, I'm not sure. If you need clarification, you can do it. I know you will. You should. You keep talking. I hear you. Well, I have the choice. Either answer is 100%. Now, negative north, though, I think you understand the opposite of north. So that's why I put that. So one system, there's reasons why you will want to use something like negative west or negative north at times. We haven't gotten to that reason yet, but here's the reason why, actually. You brought something up and you didn't ask this, but I'll tell you why. Here's why I would want negative north. And eventually, if you have a trip that's got, this is on a graph, so I can see that you actually end up at the same spot. But if I just had this data here, I would want to have everything in north and say just by the numbers, where is your final position? Started at 0. Well, I would say 1.5 in the positive north, 75. So that is 2.5. No, that? Did I do these? Oh, those are meters per second. Sorry, that's not meters. But here's what we would say. If I said just distance, that won't work. But if I said 45 north and then 15 north, that adds up to 6. And then I said, then the second part of the trip was 30 meters south, another 30 meters south. If you add up negative north plus negative north for those other 60, that are 60 plus negative 60 north, they would add to 0, which in this case is simple to see, but we're going to have some more complicated ones where you would want to put all your souths as negative north, so you do see where you come up. They're not that cool. There is a reason for those. So then, yes? I'm not going to do those questions at this. Yeah. I am going to hand out some questions, and I'm going to pause for you. Just a refresher before you get going on this. The very first question is talking about meters per second, it gives kilometers, and has hours involved. Yeah, that's exactly what I was going to do. Hey, right. And first of all, what we need to remember, I don't know if you need to write this down, but I'm going to use the word velocity because it's actually the correct word in physics if you have directions or directions of home. But do you guys remember this from grade 10? And I think you just know it because your speed, velocity, on your car is kilometers, that's a distance over hours, right? So I don't think you need to know this way. I think you don't need to write this down. You do need to know. So the other thing though is that we have one system in kilometers and one system in meters. We need to only use one system. Okay? So here's what we're going to try together. I'll get you started on the first one. Car is 22.6 kilometers north of a farmhouse, traveling 27.4 meters per second. Crap, we've got two different systems. So what I'm going to do is, so let's just say this is the house. I'm just going to say that you are at a position, I'm doing an up, down, north, south diagram. 22.6 kilometers, how many meters is that? Let's use one system. How many meters is this? Is a kilometer a lot of meters or a little bit? A lot. So it's going to be not divided. And it's 1,000 is the other. And if you forget, I have grams and kilograms up here. 1,000 grams is 1 kilogram. 1,000 meters is 1. So we just multiplied by 1,000. Usually you can do those in your head because 22.6 kilometers is the same as 22,000. Okay. And the house would be like 0. Right? And then we're motoring. 27.4 meters per second. So your velocity equals 27.4, I'm going to call it negative 27 meters per second. And negative because that's south. Yeah. That's why I'm sorting this out with my diagram. I'm saying north is positive. The other thing is that the time, crap, it's in hours. We want seconds. Go with whatever your speed is and convert everything else. So at the time, I'm not going to, the time is 1.2 hours. And I want to get rid of hours and keep seconds. I know that 1 hour is 60 minutes. 60 minutes is, once 1 minute is 60 seconds. So if I multiply for those, 60 times 60. Yeah.
3,600.
Could be a lot of seconds here, but let's get it. 1.2 times 3600.
4,320.
Okay. You guys, now that you have everything in the same system, meters and seconds, you can use V equals D over T or D equals V times T. You should be able to switch T equals D over V. You know, it's the same equation manipulated, right? To find out the distance traveled. I don't know what that is. House. Oh, it's just on the phone, dude. Okay, no. But, because you're actually asked not just how far you travel, direction, it's where you locate. So, all I'm going to say is that if you travel 50,000, then I'm going to erase this. I'm going to just put 50,000, you'd be south of the farmhouse, but you'd use arithmetic to solve it, right? You come up with a negative distance because you're traveling. And you put the starting position of, by the way, this is not a decimal, this is just a spot. Put the right numbers in. Find out the actual change in position, the distance traveled, and it'll be a negative because it's south. And you say, well, if I started at 22,600 and I went negative north, take the mathematical sum of the positive and the negative, figure out where you have. Just try. Okay, and that will take you to the end, and we will have the first question done for tomorrow, and then we'll work on the rest stuff. Okay. I use that negative. I should have put that. Was it 0.4?
Yeah, it is.
Oh, because I misread. Okay, thank you.
But are we not just putting all the questions into the formula and kind of just like divide it out?
Yeah, you can. It'll involve multiplying, but yes.
Yeah, and then I just
That's not a major
bring it
statement,
over.
that's not. Use B equals D over T, some variation of it. To figure out your distance that you traveled and in which direction.
Yeah.
And then you can find out your final position as a second step.
I'm sorry.
Okay.
Why don't we just put them into the formula? So why don't we just do?
Okay, but you don't have distance, you have a position. Here's what I'm saying. I'm going to just do an alternate. I'm going to make it simple. 0, and that's your 100 meters. You're finding the distance traveled, and if it was negative 150 meters, your final position would be 50 meters to the south of the farm.
So we're timing the velocity, we're multiplying the velocity by the time and then taking that
And you
number
get something like
subtracting
this.
it from that? Okay.
Yeah. You're using B equals D over T to find out the distance you traveled. And you say from the original spot, I would end up here. Yep. Kind of. This is why I'm helping you guys, you know. Kind of new. You're expanding on what you learned in grade 10. I'll pause the video and